Okay.
Question to the room. Who wants stickers? No one on that side. Okay, too bad. You got it. That's good. Anyone else that wants stickers? You want stickers. There we go. All right, that sounds very good. There we go. Finally, hand up on that side. There we go. Okay, now you all got stickers. Thank you. Our esteemed speaker this evening has 15 years of industry experience, during which time, part of which time, he had spent conducting research at Fujitsu on utilizing graph-based technologies in pervasive computing environments. Very impressive. Please welcome a co-founder and VP of Engineering for Stardog, Mike Grove.
All right, thank you. I feel like I'm going to be a total letdown after that preamble there. That's great. So thanks everyone for coming. Thanks for Zaid and Moody's, everyone who put this on. Appreciate having the opportunity to come out and talk to so many people who are here to be learning about Stardog and enterprise knowledge graphs. As I already said, my name is Mike Grove. I guess my claim to fame beyond having started the first lines of code for Stardog is I came up with the name. It was my 20% project back when the company was in its infancy, and which meant I worked on it nights and weekends. So my dog would sit with me at night, usually on my feet while I was working on it. So the first time I got the query engine working and got an actual right answer, which is kind of important for a database, I was like, oh, great. And I happened to be listening to an album. One of the songs of the album was called Stardog Champion. It sounded like a really cool, fast thing. The project at the time was called Slug, much less impressive and much less quick in its connotation. So I didn't expect it to kind of take off and become, what it has and have a life of its own. So that's kind of cool. So it's a bit of Stardog trivia for everyone here. Not everyone knows that story. So today I want to talk about, what an enterprise knowledge graph is, what problems that we're trying to solve with the Stardog Enterprise Knowledge Graph, what we see at companies, challenges that they're facing that we think Stardog and Enterprise Knowledge Graphs are particularly well suited to address. I want to spend a little bit of time talking about what we mean when we say knowledge graph, because I think when we use the term, it's a bit different than kind of the colloquial usage and meaning of it. So I want to just kind of put a finer definition on it and then walk through kind of the tech stack at a high level. Happy when we get to the question and answer segment to get as far into the weeds as anyone wants to. I've worked on a lot of parts of the system, so I can speak to any of it. If anyone really wants to get into the nuts and bolts, plus there's plenty of time afterwards. Happy to talk about all the fun parts of Stardog. So to kind of start, there we go. What's the problem? What are we doing with Stardog? What are companies seeing Stardog be the solution for? Well, every organization on the planet, in one way or another, is trying to become more data-driven, make more data-centric decisions, improve their decision-making processes by utilizing the data that they have in hand. And that's great. It's a very noble effort, but they're being kind of fundamentally hamstrung because this is a different way that they are trying to utilize the information in the organization. So, being projects that are data science, machine learning, analytics. They're trying to build know your customer applications, do automated regulatory compliance. What do all these things have in common? Because maybe on the surface they don't look like they have a lot in common. But underneath, kind of the one fundamental thing that ties them all together is they want horizontal access to all the data in the organization. Trying to build a know your customer application or know your patient or Star 360, fill in the blank on the wild card, whatever your industry is. You're never going to get the kind of results that you're hoping for when that 360 view is 10% of the information that you know about the customer or the patient or whatever it is in your domain that you're trying to model. And that's because organizations have kind of their data ecosystem fighting against them. It has grown organically by lines of business. You have business units that have systems that have been online for years, maybe decades, things that were built for very specific use cases, point use applications, and that's fine. There's a noble effort. Those things certainly achieve the goals that they were set out to achieve, but because organizations are changing the way they need to access and use the data, they're getting fundamentally hamstrung by the fact that all of their data is disconnected. You have all these silos spread across the organization, all these little islands of data, and that disconnectedness really limits the value that people can get out of the data, because they understand it's their most important strategic asset, but the fact that it's not connected and there's no way to have that full view of the customer is ultimately going to limit the value that these projects can ultimately realize. So, what organizations trying to do? They're trying to build bigger and bigger data warehouses. That ultimately means making more copies of the same data sets. You get into situations where now organization has 18 copies of the same single source of truth. And you don't need to be a math major to understand 18 and single source of truth don't really work out. So, and what are the other things people try? MDM. MDM, no effort, try and force everyone to agree on everything top down. Don't run into a lot of successful MDM efforts when step one's, hey, let's boil the ocean. We can't wait, we can't drive to work until we wait until all the lights are green. That's a tough sell. It's a tough thing to get over out of the gate. So usually what we find are people who say, hey, yeah, we've been doing MDM for a couple of years. We are at less than 0% complete. Because 2 years in, we've gotten no value out of it. So we basically just wasted the last 2 years. And there's data lakes. Great, all the data's in one place, but co-location is not unification. It's like putting all the parts of a car in your garage and hoping that one day you'll go out to the garage and the car will have magically self-assembled and you can drive to work. Magic isn't a very great engineering principle. So ultimately, that's not the right solution for the problems that these enterprises are facing when trying to bring together all the disparate data sources in their organization. So what is the solution? Surprise, it's a knowledge graph. So knowledge graphs try to take advantage of the graph data model, and we'll talk more about what the graph data model is. And I think the graph data model itself, graphs are certainly popular. Knowledge graphs are increasingly popular. They're going to be the data model, if they're not already, for the enterprise for the next 25 or 50 years. And we think that the only sane way for any enterprise to effectively monetize, query, analyze, and use their data at scale is the knowledge graph. And the uptake that we're seeing across the industry, the biggest companies in the world, Google, you interact with this knowledge graph every single day when you make a query. The info box there, you see it on every result page. This kind of uptake amongst the world's biggest top companies that are making the knowledge graph a central part of how they do business kind of validates that belief that knowledge graph is the way to manage the information and it's the appropriate abstraction for those organizations to use when modeling their data. So what do we mean when we say knowledge graph? What we don't mean is a data set. I had the fortune to be out in California last week speaking at the DBpedia meetup, and there was a knowledge graph meetup, and the DBpedia folks were kind of sponsoring it, and they had a couple people there from the DBpedia consortium, and I appreciate everything they do, but they kept referring to DBpedia itself as a knowledge graph, and I think DBpedia is a data set. It's some information that you could surely portray as a graph. Maybe there's some knowledge in there, but it in and of itself is a knowledge graph because it's just some pieces of information. There's no way to really make it actionable, to derive the utility that you ultimately need to get from that information. So what we mean when we say knowledge graph is taking a graph database at the core, or more generally a graph database, and being able to put on top of that knowledge toolkit, a set of things that you need to really make that information actionable, to take all the dots that are in the data and start to connect them. Because the knowledge is what you get when you connect those dots along the way. So what is the knowledge toolkit? First and foremost, it's virtual graphs. Sadly, graphs are eating the world. I agree with one of our competitors, who I won't name, who say that everywhere. Graphs are eating the world. I'd be silly to not agree with them on that when I'm saying the graph data model is the data model for the future for the enterprise. But there's a lot of legacy information. There's a lot of data in relational systems, in key value stores. There's a lot of data in PDF files and SharePoint instances. And at no point are organizations going to just mothball and shut down all that existing infrastructure and move it into Stardog or into some other graph-based system. It's just not going to happen in any realistic time frame. So how do you make it seem as if the walls between the data silos that are ultimately keeping the data unconnected, make it seem as if those walls aren't there without the actual physical disruption of breaking down those walls. So we can use virtual graphs to apply the graph data model and make all that information in the organization appear as if it was one coherent data set to all the consumers of the data. So then we take, the next two pieces of the puzzle, the business logic and integrity constraints. Zay talked a little bit about their challenges, in building and kind of utilizing their taxonomy. This is exactly what I'm talking about here, being able to provide formal, machine understandable descriptions of the business logic. To date, business logic meant engineers sitting down and writing a pile of code. And hopefully they got it right. Hopefully it was written down right because, some SME told someone who wrote it down. And hopefully that went directly to the engineer and it didn't go through a committee, and you didn't have the telephone game played between the subject matter expert and the programmer. And hopefully it didn't get replicated in Java, in a Spring app, and Ruby on Rails, and JavaScript, and a Node app. The same piece of logic built in many different ways by many different people who had different interpretations of what that may have meant. Not to mention the fact that now you have code which is expensive to maintain. It's easy to build, it's hard to get it right and hard to maintain it. So we can take that business logic and push it into the data model with these formal machine understandable descriptions of what the concepts of the domain are, and let the knowledge graph worry about the application of that business logic, freeing up engineers. I don't want to put any engineers out of a job in one at heart, to actually focus on more important parts of building the application infrastructure around the knowledge graph within an organization. And then you can utilize that same data model to state the things about the graph that must be true in the world. The constraints for the graph. The graph must be the shape, it may not be the shape. Tables must have 4 legs. I'm glad those have 4 legs. I said that one time and I pointed at a table that had 5. So glad those have 4 legs. These are simple things to write code about, and you think, okay, well, I'm fine writing Java code to do that. But when they're machine comprehensible, the machine can apply that automatically, and the nice side benefit is it can tell you why it believes something to be the case. And I'll get a little bit into the kind of fundamentals of how that works, but having the machine be able to provide you effectively a mathematical proof for why something is the case is a great insight, gives you great debugging and traceability into how the system works at large. And then finally, the last piece of the puzzle is machine learning. For us, machine learning is something that needs to be part of the knowledge graph to be kind of effectively utilized. Too often you have a data scientist wants to do an experiment, the data set's not available, they need to combine a couple different data streams, they do, and the data's a mess, so now they've got to massage it. They're taking a sample, maybe they didn't take a statistically accurate sample, but what they end up doing their experiment on is something that never existed in the real world in the first place. So now you're basing, decisions on data that isn't really real. You're not using actual information from the business, you're using kind of a fabrication. So having the machine learning built into the knowledge graph so it can utilize the information live as it stands across the organization gives you a more effective way to utilize machine learning as part of the knowledge graph. So as we go into the kind of the deep tech, I want to say deep dive, but we don't have time for a deep dive, the tech overview, I want you to think about a quote from Peter Norvig, who was at Google. He said, more data beats clever algorithms, and better data beats more data. So we think the knowledge graph empowers kind of both of these things. We use virtual graphs and the other ways to get data into the knowledge graph to give us that more graph, or the more data aspect. And then we can get better data by using a machine understandable formal domain model, integrity constraints to ensure data quality and data validation. And then we can kind of throw clever algorithms in on top by having machine learning be part of the knowledge graph. So an enterprise knowledge graph, it looks kind of like a cotton ball on top of a bunch of boxes. Really, and so the idea, these are data sources, all the silos across the organization, and we're using that data model, that declarative business logic, to be the glue. That's the abstraction layer that lets us act as if all these different siloed domains are all one cohesive unit. and start bringing together a complete, cohesive, accurate picture of all the information in an enterprise. So where Stardog kind of fits in kind of the lay of the land is Stardog, not surprising, the dark blue box that's labeled Stardog, and here the declarative model. So, again, this is the glue layer. This is what provides that graph abstraction over things that inherently aren't graph data. That lets us tackle, which is often forgotten, via big data variety. And we use that to bridge together structured, semi-structured, unstructured data and give them the appearance to all the people consuming the information, all the analysts, people building point use applications, data scientists, that single coherent picture of all the information in the enterprise. Because someone who's trying to build that know your customer application, who's trying to build an automated pipeline for calculating bank liquidity, they don't actually care whether something was in Postgres or Oracle, whether it came from Mongo or Cassandra. These details really aren't relevant for them. What they need are the right answer and all of the data. We talked a little bit about how unconnected data is a liability. It's a liability for someone like a bank who's doing a liquidity calculation. That's a legal liability. You get that wrong, in theory, someone goes to jail. For B2C corporation like a Best Buy or a Mattel, that's missing opportunities to effectively market to your customers and provide them products that they actually want to buy. So that's a monetary liability for them. So this is kind of a zoom in on that dark blue box, and we'll step through the different parts and pieces of this as we go along. So just kind of showing how graph data, unstructured content. RDBMS here is just a stand-in for anything that isn't graph data that's in Stardog. And bringing together all of those things, you see all the arrows kind of end at the query engine. So the unifying layer for us, where we apply the graph data model, is in the query engine itself. So the graph data model. Pretty straightforward. Nodes and edges, labels on the edges so you know what they are. How many people have worked with graph technology before? All right, keep your hands up. For those of you who have worked with graph technology before, put your hand down if it was Semantic Graphs, RDS, Sparkle, OWL. So a couple of you guys keep a note of, you're a support group now. You've been using the wrong graph technology. I hate to tell you that. It's not fatal. It can get better. You've just been using the wrong technology. So the right thing to use are semantic graphs. So semantic graphs, this is one of the questions during the trivia round, are W3C standards like HTML and HTTP. These were put together by folks at the W3C who thought long and hard about what it means for how a graph data model should work, what the semantics of that should be, and exactly how that's formalized in a very coherent way. It gives you, this, as I said, this declarative model for defining, what it is to be a customer and make a purchase, what it is for a trade or a transaction to go through, and it has a party and a counterparty. And this is the mechanism by which we can encode the business logic into the fabric of the graph itself. This lets us operationalize that data model. So more data. Before we go on, we need more data. We need lots of data. I said we can't have the customer 360 application without the 360 view of the data. So virtual graphs is the way we accomplish that, bringing in all the data in the enterprise that's inherently not graph shaped. This is another W3C standard that we use called R2RML. And that's how, for relational sources, we're using this technology to kind of bridge the gap from relational to graph. So, and I'll walk through kind of a little example of it. And we can use these declarative mappings. This is a theme, declarative, to tell us how the concepts in the relational database, those tables and those rows and those columns, use just a plain old query mapped to the concepts in the domain, mapped to that domain model that we're using to unify all the different data sources in the knowledge graph. So, relational table, this is basically every relational database on earth looks like this. Some are more complicated. Again, this is kind of a cartoonish way to just visualize your basic tabular data in a relational system. So how do you get this into a graph? So basically, you make a template. So I don't know how well everyone can see that. Kind of these ending nodes and edges are variables, effectively. So you can think about it like a program. And we're going to take this template and we're going to apply it to that table. So when we apply to the first row of the table, we populate those variables. And now we have a graph. And we can do it again and again. And you can see, as we apply that template to the table, we can kind of iteratively build up a graph. But what we're doing, this is kind of a simplified version. What we're able to do this at query time. So we don't actually have to materialize any of this data into the graph. We don't force you to take the data out of the source systems, or we don't want you to make another copy. We'd really love people to stop making copies of data. If you want to move it into Stardog and mothball a system, that's a great achievement. Retire that old Sybase system in the basement that everyone's been afraid to touch since 1988. But you don't have to. We can use these templates. We can use the mappings on the fly to drive query answering. So, again, we're able to apply that graph data model to these relational sources on the fly, give them the appearance of being inherently graph-like. Unstructured data too. So, we use a system called Bytes to do this, and I'll walk through the workflow of that. Basically, unstructured content. This is one of the themes at the meetup last week. They're saying that unstructured content and structured content in an enterprise is like the ocean, and the structured content are little tiny islands, and all the water around them is the unstructured data. Organizations are kind of coming around to this reality. They have huge SharePoint instances. You have massive amounts of kind of actionable insights in emails. You can think about how much you talk about day to day in email and Slack, all that content that is just otherwise uncaptured. So being able to bring that into the knowledge graph using our system called Bytes, is kind of the goal there. So we're not NLP guys. NLP is a hard thing to solve. We operate in a lot of different industries. We don't have like a NLP solution. What we do is we try and play nice with whatever your NLP solution is for your industry. What you need for extracting information from financial contracts is a lot different what you need for extracting information from doctor's notes when trying to put that into patient healthcare records. So, the idea of Bytes is to, this is kind of a zoom in on the architecture that we saw earlier. Take your unstructured content, I'm going to pass it through. Fortunately, PDF's actually great because PDF's got RDF embedded in it directly. But PDFs, Word documents, anything in the Office suite has a lot of structured metadata in it already. We can automatically put that right into the knowledge graph. And we can pull out the text, and we pass that on to third-party NLP, something like Gate and Mallet, IBM Open Alchemy, Open Calais, if you want a free service. And all of that content comes back, is put into the graph index. The text is put into the full text index, so it's searchable, so you can do fuzzy searches over the text documents, get all the metadata about them, all the extracted content from the NLP about it. And then the documents themselves are put into HDFS, S3, whatever kind of Glacier type storage to be able to serve them back to people. So then you can effectively do queries over the knowledge graph, all the documents that correspond to these entities that talk about these things that happened in this time frame, join that with other information that's relevant to those topics that may be spread across the organization, and start to make all of that dark data a little more actionable. So again, just to kind of recap, we're using the virtual graph technology and Bytes to help us build this picture, help take all these different data sources and data silos across an enterprise and give the appearance of this kind of more cohesive picture at the top, and that's what people are going to ultimately pull data from. So better data. For this example, we're going to basically use movies. Movies are an easy thing to talk about. I'm not a financial expert or a healthcare expert, so it's easy for me to sound like a complete idiot when I try and dabble in those domains. Movies, I kind of get. They're an easy thing. Everyone's got their movies they like. They understand the domain model kind of natively. This is a pretty simple representation of what that would look like. Movies were filmed in places. They have documents about them, the scripts, Rotten Tomato reviews, all the people associated with it, actors, directors, sound guys, writers, producers. And these things are made by organizations, production companies. So what can we do with that data model? So if you think back to the original graph that we had, so that was kind of some fake movie data. Well, it was real movie data. It was pulled out of IMDb. But we can apply this data model to it and use reasoning. So reasoning is basically the process whereby we make implicit information explicit. So we take advantage of those declarative definitions and we derive new knowledge. And all of these things are written in a very simple, easy to use language that you don't need to be an engineer to write. It's hopefully something that's pretty understandable for an SME to kind of put down their thoughts and capture exactly what they believe to be the understanding of the world, in these domain models, so they can be actionable in the knowledge graph. So an example of how this works. So, this is a really simple data set, a couple of movies, actors and directors, an actor, an actress, and a director. And these are our explicit facts. We know that these people acted in the movie. We know Gareth Edwards was the director. So that's fine. From Inferno, I can figure out who the actor and actress was, Tom Hanks and Felicity Jones. That's great. But once I'm at Tom Hanks, there's no way for me to find out what movies he acted in. Those are directional edges. So intuitively, I know about this domain, actors and inverse relationship. If Inferno had Tom Hanks as an actor, Tom Hanks acted in that movie. So I can put that as a definition. And this is the exact syntax you would use, and say actor and actor of their inverse relationships. And now these light gray edges are kind of dynamically added to the graph. So now I've got those backlinks. I've more effectively modeled what I believe to be kind of the relationship between actors and movies. Maybe for the analytic I'm trying to do some sort of social network analysis, and for my use case, I don't necessarily care whether or not the person was an actor or a director. Doesn't matter if they were the sound guy. I just want to know who worked on the movie. Well, I can say there's a generalization of that concept called worked on. So then I can kind of overload that edge of actor or director. Now it's independent of the role that the person had in the movie. We just know they worked on the movie. So again, great, but I've only been connecting things that were already connected. What happens if I want to start building that social network? I want to start connecting the people that were kind of in my world that were previously unconnected. Well, I can understand that if Tom Hanks worked on Inferno, Felicity Jones worked on Inferno, kind of means they're coworkers, right? So I can state explicitly that co-working relationship, having both worked on the same movie, is what it means to be a coworker. So now I have a formal definition of that relationship, and I've gained connections between nodes that were never connected before. And kind of taking it one step further, probably everyone's heard of the 6 degrees of Kevin Bacon. He's so prolific that everyone's connected to him, and in up to 6 hops. Easy thing to write some code to figure out someone's Bacon number. Well, you don't have to write code anymore. We can actually define how we can kind of walk over those coworker relationships, and then if we count the edges, that's the Bacon number, because it's a transitive relationship that we can follow throughout the graph. And through kind of 4 simple definitions with 4 explicit facts, we've gone from there to I think 16 facts that we have now. So we've quadrupled the amount of data we have without having to write anything to the system. Only burden on us was to just kind of codify what we know about the world. So we've gotten more information, we've got a better view of the world, and we didn't have to write any code to be able to enrich our data set. So you can see this is kind of just the thumbnail of how you can begin to use this functionality to push data or push your business logic out of the code and into the data model. So, what's going on there? We're able to use those definitions at query time to change your queries effectively. We're able to say, hey, well, when you said worked on, you want all the people who worked on the movie Inferno. I know that you meant anyone who was an actor or director, a writer, the sound guy. So it kind of uses that explicit knowledge that you've encoded in the domain model automatically for you so that you can write more kind of coherent, high-level queries that better represent the question you're trying to answer without having to worry about writing code or writing a really gnarly SQL query. And ones who worked with SQL can think of that one SQL query that they had to write that they're ashamed of, but that it did the job. So everyone's been there. And the nice thing about Sparkle, like SQL, aggregates, grouping, filtering, it's a very easy step from SQL to Sparkle, so it's a pretty familiar way to be able to take advantage of, the process of reasoning without having to worry about, all the bits and pieces that come under the hood. And, as I said before, and I'm going to go back one, these gray edges and kind of the definitions of the world there on the right side of the slide, those are kind of live in Stardog. It knows about all that stuff. So when I say, okay, you've told me that Tom Hanks and Gareth Edwards are connected to each other, but, if this is what I think the world is, I don't understand why that could be the case. Maybe I don't know what the rules that you had are. Maybe I don't understand how they work. Why are Tom Hanks and Gareth Edwards connected? So we can kind of backtrack and say, well, they're connected because you told me that connected to is transitive. It follows this coworker relationship, and we understand that coworkers are people who worked on the same movie. So we can provide that back as a formal proof, just like you had to do in math class in high school. So it gives you insight into the system, and as soon as you change any of those definitions, you can run the same query and see kind of the turnaround on the business logic live. You'll get different answers as soon as you make tweaks to any of the definitions on the right hand side. So you're looking at it and saying, well, I didn't actually mean for them to be connected. I wanted the connected to relationship to work a bit differently, so you could tweak that definition and you don't have to recompute anything. The next query answer will take that into account. So again, going back to the data model, we want to talk about integrity constraints. So we understand, again, for the domain, movies had to have been filmed somewhere. They have to have at least one location. They have to have at least one writer. Usually only have one director. Sometimes directors get fired. So I guess you can have previous directors, but only one director, usually a production company, usually one script. So these are the things you can start stating formally about the world, so that when there are two different scripts, you could get an error. Like, a movie can have two scripts. One of those has to be the previous script. And you can kind of have a different relationship to show that lineage of maybe how the script evolved over time. So, this is kind of our fundamental building block for ensuring data quality. I used the example before about saying tables have to have 4 legs, employees have to have an employee ID, U.S. citizens can have one and only one social security number. These are all constraints, again, that, it's easy enough to write in Java or C++ or C# or whatever your language is for kind of building that middle tier application infrastructure. But the point is, you don't have to. You can reuse the same infrastructure, the same syntax, all the same mechanisms that we're using for the reasoning process to be able to apply these constraints to the data model. So you have all the same power and expressiveness, but you're able to put that into the knowledge graph so it's automatically applied by the system. A couple other kind of aspects of adding better data. Not all the data in the graph is, a node and an edge. Some of the nodes are, inherently text-based. So we talked about, something could be a summary from Rotten Tomatoes. So that's data you want to be able to do full text search over. Stardog will automatically index all of that stuff with Lucene and put it in so that you can do full text searches. Now all the results that come out of Lucene, you can then join with the results coming in from relational systems, from Stardog itself. You can leverage any of the automated reasoning process to get more data out of what otherwise would have just been simple text search results. And similarly, geospatial, some of that data is latitude and longitude, some of it's places. So that gives you kind of primitives for saying I need all of the French restaurants that are within a 5-minute walk from my current location that have gotten 3 stars on Yelp and aren't too expensive because payday's coming up and I don't have a lot of money on hand. So that's an example of how you can use the geospatial aspects, integrate third-party data like something from Yelp with information that you already have at hand if you had a database about restaurants and their ratings. So clever algorithms, kind of the last piece of the puzzle. This is where we bring in machine learning. And I hinted at why we think machine learning is kind of a good thing for the knowledge graph, where data scientists are spending a lot of their time creating data sets just so they can do their job. I've heard up to 90% of the time spent fighting and wrangling, munging the data set, and then the other 10% is actually doing the job that they were tasked to do. My engineer that helped me build the system, that he spent a lot of time as a data scientist, and he was building the thing that he wanted to have. As a data scientist, he was like, I want to build a thing that scratches my itch, that would have made my life better. So being able to put machine learning into the knowledge graph, we're able to address a lot of his issues with coming together with an appropriate data set, train a model, how to operationalize it, and how to actually utilize it, within the larger ecosystem. So, sticking with the movie theme, being able to put together, data sets like IMDb and Rotten Tomatoes information and do similarity prediction. So, what we want to use machine learning for in this example is regression and classification. So regression is predicting a value, guessing the IMDb rating from kind of the physical data we know from just who acted in the movie, what their genre was, and so on. And then similarity, classification, finding movies that are similar to other movies. So for learning a model, this is exactly how you would do it. So this is a kind of example of a Sparkle query. The where clause here at the bottom is the declarative definition of what our training data set is. In this case, I've done some feature engineering in my head, actor, director, keyword. I think those are the salient things that go into predicting whether two movies are similar. Obviously, that's kind of an oversimplification, but, when I run my experiment and I see the results aren't very good, I can then drop that model, add some new arguments, rerun that query, and I've trained a new model. It's immediately operational for me to then check my results. So an example of that, using The Godfather, again, my simplistic modeling of the world, director, actor, and keyword, I can get similarity predictions. The confidence levels aren't great, but those are actually pretty similar movies. So, but maybe I'm not excited, as I said, about the confidence levels. I can go back and tweak it, maybe get genre included, maybe get some other metadata, pull in things from Rotten Tomato and get sentiment analysis on reviews, whether or not these things were reviewed similarly or had similar keywords in the reviews, and take that into account and maybe get a better, more robust set of similarity predictions with better confidence. But this is an example. As soon as I've run this query to train the data set, and I know exactly what's gone into my training model, there's no doubt about it. It's exactly the subgraph that corresponds to that part of the query. I can turn around and use it. I don't have to move it anywhere. There's no massaging it. It's done over the live data in the knowledge graph. So there's no doubt about the veracity or correctness of the data. I'm using the same data that everyone else in the organization is using to build their applications on top of. So all this is based on a system called ValPal-Wabbit, which is a really cool online logistical regression library. It's what's behind Microsoft's Azure machine learning capabilities. It's embarrassingly fast. It can train its model faster than we can put the data into it, which is great for us because as soon as we speed up Stardog, all the machine learning stuff gets faster. Offers a lot of kind of native machine learning algorithms and functionality that we can take advantage of and kind of bubble up through those queries to any of the people who want to start utilizing the machine learning algorithms on their knowledge graph. So what else are we going to do with this? I said we didn't have an NLP system just because NLP generally is hard. There wasn't anything out of the box that we're going to roll into Stardog that was going to work well for anyone. So what we're looking into is an area called knowledge-based construction. So it's the idea of basically taking unstructured content and creating structured content out of it, but using kind of an iterative developmental approach, very similar to the way an engineer would address performance issues, where you'd run it, you look at the profiler, you'd see the line of code, or the section of code that's kind of the hot spot, and you tweak that, you run it again, it's probably going to be a different hopefully it's a different hotspot. You tweak again, and eventually you end up with kind of the right performance that you need for whatever you were trying to accomplish. The same idea for what we're doing with knowledge-based construction. You have a knowledge engineer, someone who kind of understands the domain, who knows the domain model, and they're going to write rules. Again, declarative mappings from how the content gets extracted from these blobs of text and turned into structured information. So they can run that process, look at the results and say, hey, well, it was pretty good maybe for the films themselves, but it did a really bad job on picking out the actors. Let me go tweak the rules for that, rerun it again. So it gives you the same familiar iterative approach for being able to extract content from unstructured information without having the system itself being overly biased towards one field or another, since you can fully customize how the extraction happens with a rule set. Rule learning. Alex at Moody's will probably tell you, ontology modeling is not always the easiest thing to do. He's smiling and nodding. And even if it is really easy, if you have a complicated domain, it can be tough to get started. So what organizations have a ton of is data. So what we want to be able to do now that machine learning is part of the system is, I apologize for the pun, eat our own dog food, and use the machine learning algorithms and apply those to the data that we've been given as part of the knowledge graph, the raw data, and say, well, we can kind of understand from how the data is used in the organization, maybe look at queries from applications that use that data, and be able to understand the patterns in it and suggest rules, suggest axioms, suggest the data model. Because if we can get 50% of the model right, that's a ton of upfront human capital that's saved. So then you can just kind of sanity check that half and build the other half of the model. So that's a big win for being able to get up and running with the knowledge graph. Also ontology matching, understanding that maybe two data sets, see if they're identical, if they have identical concepts. One thing that organizations struggle with, and it's a hard problem, is understanding if M. Grove, Mike Grove, and Michael Grove are all the same person. And in places where I'm talked about as a programmer, and other places where I'm talked about as a University of Maryland alum, is that the same individual? Is that the same concept? So being able to, again, look at the actual data and be able to suggest, given your domain model, these entities kind of all correspond to the same type of thing. These are the same types of individuals, and ease that burden of aligning data sources as you bring them into the knowledge graph. Other things that we're looking at for machine learning, as I get into the roadmap here, unsupervised learning. The reason we pick supervised logistical regression is computationally, it's not a big sell. For doing deep learning, it tends to be a pretty hardware-intensive thing. So for organizations that have a relatively straightforward Stardog install to say, hey, you also need 1,000 nodes to use the machine learning stuff. I know you've only got a 3-node Stardog cluster. That's kind of an awkward conversation to have. So the Val-Wabbit stuff, that's part of the reason why we chose it. It naturally meshed with how Stardog itself was designed. But unsupervised learning, deep learning, neural networks, these are all different algorithms, have different characteristics, and they'll fit into this different system a little bit differently. But there are things that we're looking at to extend out those capabilities to give organizations more options when using that part of Stardog. What else are we working on? Extending virtual graphs to all of the different enterprise data sources. Relational isn't the only thing out there. There's other graph sources, sadly. Key value stores, HDFS, data lakes, being able to take advantage of all that data no matter where it is, what it looks like, and bring it into the knowledge graph. Our new backend based on RocksDB, hopefully will be out next month. That'll double or triple our scalability. We're a scale-up system. But after that, the next step is horizontal scalability, both for query evaluation and for storage. GraphQL support, recognizing the fact that while Sparkle's a pretty effective query language, there's a whole universe of engineers for whom the semantic web stack, Sparkle, are completely foreign, or maybe they know them and they just don't want to have to write a query. So working with JSON and particularly GraphQL is an easier sell, an easier way to get up and running. So give that option for people who are building applications on top of the knowledge graph. Stardog Studio, basically an end user IDE for anyone working with Stardog. Give them a friendly environment with syntax highlighting, auto-completion, ways to visualize the graph, way to visualize your ontology, create your data model, iteratively build a query, look at the query plan, see where it's slow, tweak it, maybe add a hint, see the cardinalities and understand why the performance of the query is the way it is. See the explanations. We talked about how Stardog can give you a proof for any of the inferences it derives, be able to show those in a more human-friendly way. These are all things that we're going to make part of the Stardog Studio. And then enterprise search integration, being able to tap into enterprise's existing investments in Elasticsearch and Solar, bring those into the knowledge graph as well. Oh, did it? There's some technical difficulties. I don't know how to use one of those machines. I'm embarrassed. All right. So the TLDR, I guess technically I should have done that at the beginning. Sorry. So why should you care? What are people doing with the knowledge graph? You know, as I said, it's our mission to help organizations connect unconnected data, more effectively use the data they have in their organization. As a company, we've been in business since 2006. For the first 6 or 7 years of our existence, we were mostly government-funded R&D shop. We understood, we incubated out of a research lab in Maryland. We understood what graph and AI and what these technologies could do, but we didn't know what exactly the problem was that they were best suited to solve. So the best way to figure that out is actually go out and use them. So we spent a lot of time, in particular, using the technology at NASA, where the project started off as, we're spending millions of dollars a year trying to find people in our organization. We don't know who's good at jet propulsion, which is kind of ironic. The organization that put people on the moon can't find the people who are good at something. But I guess that's a harder problem, maybe. So they were spending millions of dollars a year on commercial off-the-shelf software. And when we talked to them, we said, well, you know who works there. You have all the employee records in LDAP. You know who bills to what projects. You know what people are working on. You have all the publications of all of your engineers. So you can have an idea of where their expertise is. So when you take these isolated systems and start putting them together, there's their expertise location. That's your comprehensive description of who works for NASA, what they're good at, and what they work on. So when you want to find the next set of engineers to help you design the space capsule that goes back to Mars and the moon, you can just look at your own data. You don't have to have some expensive system to be able to help you do that. I said, great. We would love it if you helped us do that. We said, how about $1 million? How about 50,000? So we said sold. And that was basically the start of the company. And that effort has continued from the early part of the 2006-2000 timeframe. And now the goal of that is to get that knowledge graph into mission control, so that when an orange light goes off at T-minus 12 seconds and some part of the launch vehicle is malfunctioning, they can say, okay, who built it? Where was it built? Where are the blueprints? How was it manufactured? Who's on call right now? Who can I get on the phone to tell me, can we go or not go? So as an example of, they started very small, it was a very modest goal. Hey, let's just find who's good at things here at Mother NASA. And kind of the end goal of the project is getting into mission control and helping them make a better decision of whether or not they can send the spacecraft up into the air, up in outer space. So, long story short, that's the kind of thing that we're trying to help organizations build, the problems that we can help them solve. And, I think, it's an applicable thing at every organization. We help people in manufacturing, healthcare, financial, being able to bring together all the disparate information, connect all the data and otherwise unconnected silos isn't a problem that's industry specific. Everyone has it. And using enterprise knowledge graphs are the way to solve that problem. If you want to get started, you can download a trial from Stardog.com. Really easy. Your only requirement is Java 8. Unzip it and go. Identify 2 related data sources that you'd like to glue together. Or if you already have some RDF data and ontology, you can just throw that into Stardog. Maybe you just want to replace another graph database that isn't working out so well for you and you have some graph data at hand. Easy enough to load that in. If you're mapping relational sources, you create your data model, the mappings, for this concept in the ontology, it goes to this table, this row and column, this SQL query, and then you build a query. What report am I trying to create? What insight am I trying to derive? To effectively build a query that will help you get the data out, and then hopefully the end goal is some sort of profit. You've effectively brought together 2 data sources that were never meant to work together in the first place, and you've answered a query, answered a question that was otherwise a challenging thing to help you answer. resources for getting started. I'm contractually obligated to tell you our docs are fantastic. They were written by my co-founder and our CEO. But seriously, they are very comprehensive documentation, hopefully very accessible if you want to get into the system. Everything is detailed in oftentimes excruciating detail. Unless you're a Windows user, you're pretty much out of luck. Sorry. We're not a big Windows shop. Our blog, a great place to read about what we're doing, how we think about the world, what our engineers are up to. It's written by all of our engineers. So it's not any marketing or sales fluff. If you want to actually understand why the machine learning stuff works the way it does, that's on the blog. If you want to understand how we're designing a new storage layer and building it on top of rocks, the motivations behind doing that, that's also in the blog. So some fun bedtime reading, if that's what you'd like to read at bedtime. Stardog examples. Most of Stardog is written in Java, so the examples are in Java. But there's plenty of community-supported libraries, .NET.RDF. For folks working in C#, there's Clojure, Ruby. I think there's a Python binding out there. The link at the bottom is our official Stardog.js is a node package for working with Stardog from the JavaScript world. If you're a Spring shop, Stardog Spring, we've got some bindings for Spring. And if you want to use Stardog on Amazon, we try and make that easy for you with our open source tool called Graviton. Basically, I want in US East 1 a 3-node Stardog cluster. Have at it. Here's my AWS credentials. We'll spin it up. We'll create the EC2 instances. We'll provision the ELB instances. We'll connect them up. We'll set up the security zone so people can't get to your data, and basically just give you back the endpoint. Here's the URL to your Stardog cluster, and then you're ready to go. So we've got plenty of time for questions, I hope. Thank you, everyone.
Before we take questions, I just want to remind everyone, we are giving away these orthodynamic planar magnetic headphones. Everyone has to have their card in this pouch. If they don't, I guess come up now and throw it in. If you don't have a card, you can make one on a piece of paper. I'm going to leave this right here. We're going to give the headphones away in about 5 minutes. Let's take the first question. Yeah. He's asked if GPUs are becoming more popular.
They're becoming more popular. Where we're seeing them used a lot is in just kind of the raw analytics space. There's some systems out there that are taking advantage of that, map and scatter, or gather scatter algorithms and being able to do large scale traversals over big graphs. So it's an interesting applications of GPUs. That's certainly something that's becoming more and more popular. It's not something that we've looked at too closely for Stardog itself.
Next question?
So you mentioned it's a cluster.
Mm-hmm.
So it's a graph distributed across the cluster. And so what kind of replication is there?
The graph it's a scale-up system, so all the nodes are fully replicated. So it's strong consistency, ACID transactions, two-phase commit over the cluster. So every node in the cluster has an identical copy of the data. We handle all the replication for you, so when you write to the system, it'll end up on all the other nodes. So as soon as, hopefully none of them ever drop out, but distributed computing's a pain. One of those is eventually going to drop out. One of the other ones has got a complete copy of the data and it's ready to go. It's not for, it is primarily for high availability. You get linear scalability on reads because they're all identical copies. So if you need to double the amount of read volume, you can handle just double the amount of nodes. Obviously that kind of is an inverse relationship with two-phase commit over a cluster with writes. On paper, it should be a constant time write penalty, but you're going to saturate the network at some point. Is whatever you can fit on the single machine. So currently that's about 50 billion edges. The new back end should get us to 150 billion edges. In theory, with using rocks scales for as much disk as you have. So technically, on paper, we will scale more than that, but it never works out that way. I'm expecting the new ceiling to be operationally about 100 billion, 150 billion.
Hey guys, I'm AJ. I work with Mike, and I'm going to give the microphone to whoever has a question going forward because we want to make sure we can hear everybody. In reverse, that question was actually about how Stardog's cluster is made up and what the purpose of it is, to which Mike was answering scale-up database and that it offers high availability and ACID redundancy. Who has the next question? Thanks.
So in one of the slides, I remember reading keyword searches are not enough. So another way of understanding that point is there are another methods or there are other methods of querying or traversing the data?
Yeah, so if you're using something like Lucene, you're saying find me all the documents in Lucene that match this token or have this token in it, doing fuzzy matching, using wildcards in the token. So great, you found a document in Lucene that had the same kind of text, but that doesn't tell you more about what that thing is, and it doesn't connect it with the wider data ecosystem. So being able to find the related things in Lucene isn't sufficient for being able to find data at large.
Anyone, next question? Everybody on that side of the room?
We'll come over there next.
What kind of data about the graph is in the graph? Like how in Mongo or MySQL there will be admin tables, and also do you know of any use cases where people are perhaps programmatically altering their rules and constraints and things like this?
Usually the rules and the constraints are an upfront thing. Certainly they're able to be altered programmatically, and that'd be kind of an interesting thing to try out, to have kind of an adaptive system where you can tweak that stuff on the fly. But normally someone sits down up front, the SME models, some part of the business logic and the ontology. There was a first part of the question that I didn't quite.
Oh, what kind of meta information is in the graph? So is any information about the graph or?
Yeah, this is a nice thing about graphs. They're flexible. Just add more nodes and edges and you've got more data. So the data model itself is actually physically in the graph with all the other data, so it's self-describing. And then you can basically say things about the graph itself. So you can attach information to a node and an edge and say more about that relationship. So you can attach provenance information, when that relationship was valid, who said it, the veracity of it, if it was, word of mouth from a president who doesn't have a great relationship with the truth, maybe you want to discount that versus something that came from another outlet.
Next question?
Hey Mike, while I'm walking over, could a Stardog user apply different sets of rules or constraints at query time?
Thank you for the softball. Yeah, this is the nice thing about having the data model as kind of an explicit artifact. You certainly get into fights between parts of the organization where they're like, no, I really like saying tomato, and someone else really likes saying tomato, and it just becomes kind of a culture war, tabs versus spaces. Any fans of Silicon Valley know that's apparently breakup worthy, but you get those kind of fights in an organization about what things are called and how things are modeled. So the domain model can be a thing that acts as a lens, so I can look at the data with my view of the world, the things that I think about with the data model, the things that are important for me for my use case. The ground facts don't change, that someone is connected to something else, that a trade was made, that a customer made a purchase. Those are things that are true forever, but what that means to someone who's doing analytics can change depending on their point of view or what they're trying to get out of the data, so they can have different ways they apply that data model to the explicit information.
We have time for just one last question from that guy over there.
I'll just yell, it's fine.
Okay.
Do you guys have any current or future capabilities around ontology versioning, or any best practices in terms of modeling to handle ontology versioning?
We do. We have. I don't want to call it Git for graphs.
It is a graph.
Yeah, and Git's like a hard thing to use. We tried to build a very stripped down notion of it. You have kind of a subgraph that you want to attach a version identifier to, commit changes to, have the ability to refer back to it, so you can manage your ontology that way.
I want to fit one more in since this gentleman had a question. That's the last one.
Thank you. Do you have any use cases of Stardog being used as a collaboration tool among different organizations, or is this really just intra-organizational?
Probably the closest use case for that amongst different organizations might be by the EDM Council. So the EDM Council is a consortium of different financial organizations to try and build an artifact called FIBO, the Financial Instrument Business Ontology. So to codify, to create a domain model the business logic of what it is to be a trade or a loan or a mortgage. So all of that was built on top of Stardog. We gave them the software, and they have a check-in pipeline and CI. So that's probably the closest thing to multi-organization collaboration.
Do you think that there's an opportunity with a Stardog platform for like a differential privacy environment that would allow multiple industry contributors to participate?
That's certainly something we're looking into. Privacy concerns are obviously at the forefront after what happened with Equifax and organizations trying to increase data sharing, but you also don't want to show your competitors kind of your moat, your competitive advantage. So be able to collaboratively share data, but not give up, the special sauce, as it were. So differential privacy, blockchain, are some interesting applications of using those processes within the knowledge graph at large.
Okay, Mike will be here for one-on-one questions right after our raffle. So as soon as we're done with the raffle, just come right up and ask away. Thank you all for coming. Thank you, Mike Grove. Thank you. We are now giving away these orthodynamic planar headsets, headphone. I would like to ask, let's see, can you mix it up? Okay. Okay. Can I ask you, look that way and reach in and pull out a card. What's it say?
Michael Thomas.
Michael Thomas? That's you. You won these headphones. Thank you all.